Welcome back, friends. In the previous session, we have seen for cos omega naught t, what is the Fourier transform we got? X of omega, which is nothing but pi delta omega minus omega naught plus delta omega plus omega naught. This is what we got. So in the similar way, cos 2 pi f naught, same thing only, but in terms of frequency f, if I write x of f, then this is going to be 1 by 2 delta f minus f naught plus delta f plus f naught. So this is what we got, and we have drawn this x of f also with respect to f. So it is having two impulse functions. One is at minus f naught and plus f naught, and they have an amplitude of 1 by 2, 1 by 2. This is what we have seen. Now I want to go for sine omega naught t. Let's say sine omega naught t. Sine omega naught t can be written as 1 by 2 e power j omega naught t minus e power minus j omega naught t. This is the we can write. So for this one, if I go for x of omega, so here 2 pi delta omega minus omega naught. So if I take 2 pi common out, so this is going to be, and one more thing I forgot. So here it is 2j, not 2, it is 2j. So pi by j delta omega minus omega naught plus delta omega plus omega naught minus. So for this, if I write x of f, this is going to be 1 by 2j delta f minus f naught minus delta f plus f naught. So take this 2j inside, then if j goes to numerator, minus j by 2 delta f minus f naught plus j by 2 delta f plus f naught. So this is the way we can write. So if I write x of f, so here in the previous case we don't have any phase, so we simply having delta f minus f naught having amplitude is equal to 1 by 2, delta f plus f naught having amplitude is equal to 1 by 2. But in this case we are having a j term, that means it is having the phase also. So while we are writing x of f, so we have to go for both magnitude spectrum as well as phase spectrum. So if I say mod x of f, with respect to f, if I draw it, so at f naught and at minus f naught we are having impulse functions, and they have, so 1 by 2, amplitude is 1 by 2, but phase is equal to minus 90 degrees and plus 90 degrees. So at f naught we have amplitude is equal to 1 by 2 only. Here also 1 by 2 only. But if I take angle of x of f, magnitude spectrum, then at f naught we are having a phase of minus 90 degrees, and at minus f naught we are having phase of plus 90 degrees. So the only the difference between sine spectrum and cos spectrum is the phase, if you observe carefully. So here we don't talk about the phase spectrum here because phase is nothing but 0. But here we have to talk about the phase spectrum also because we have some phase. So only the thing is sine lags cos by 90 degrees. That's what it is saying actually. So here for cos wave the phase is equal to 0, but here sine wave the phase is equal to minus 90 degrees. So sine wave lags the phase wave by 90 degrees. Clear? This is only the difference. So take it. Modulation property. Modulation property. So we know for x of t signal, x of omega Fourier transform. If I ask what is the Fourier transform for a signal which is multiplied with cos omega naught t, what is the Fourier transform for this? Now if you observe carefully, this can be written as 1 by 2 x of t e power j omega naught t plus 1 by 2 x of t e power minus j omega naught t. So for this function, if I calculate the Fourier transform, now for x of t, if it is x of omega, so x of t e power j omega naught t is nothing but x of omega minus omega naught. So if I take 1 by 2 common out, then it is going to be x of omega minus omega naught plus x of omega plus omega naught. So this is what the Fourier transform for it. Now, so you may not identify anything here, but if I go for spectrum, that means the pictorial representation, there you can understand what exactly is happening here. So let's say, let x of t having x of omega, which is like this. So let's say minus omega m 0 omega m omega. So magnitude is a. Magnitude is a. Now if I say x of t having Fourier transform like this, then what is the x of t cos omega naught t having Fourier transform? What is the Fourier transform looks like this for this? Now observe here. First, x of omega has to be shifted rightwards by omega naught. X of omega plus omega naught, that means x of omega is shifted leftwards by omega naught. And what will happen to amplitude? That will become half. That means this spectrum amplitude is reduced to a by 2, and one is shifted to omega naught, another one is shifted to minus omega naught. That's what it is happening. So finally, we are going to get spectrum which is like this. It is shifted to omega naught, so it is omega naught minus omega m, omega naught plus omega m, and it is shifted in the leftwards also by the same amount. So it is shifted to minus omega naught. So it is going to be minus omega naught plus omega m, minus omega naught minus omega m. So what is the amplitude will become a by 2. This is the peak value will become a by 2. That means the same spectrum is divided into two equal halves. One is shifted to omega naught, another one is shifted to minus omega naught. That is what is happening here. Clear? Take it. So this is actually a very important property in the communication system where modulation is applying. So this is what is exactly happening in the modulation. This property can be seen for x of f also the same way. Suppose x of t having x of f, then if x of t is multiplied with cos 2 pi f naught t, then having Fourier transform, one is 1 by 2 x of f minus f naught plus x of f plus f naught. Both are same. Again here also it is divided by half. That means the spectrum is divided into two halves. One is placed at f naught, another one is placed at minus f naught. That's what the meaning of transform for this. cos omega naught t u of t. For this one, what is x of omega? That was the question. So let's see how we can do this. So don't go cos omega naught t and u of t. So first we know u of t. For u of t, what is the Fourier transform? 1 by j omega plus pi delta omega. This is the Fourier transform. If it is multiplied with cos omega naught t u of t, then what is the Fourier transform? 1 by 2. Let's call it is some x of omega. Then what will happen? X of omega minus omega naught plus x of omega plus omega naught. So this is nothing but omega minus omega naught. J omega minus omega naught plus pi delta omega minus omega naught plus 1 by j omega plus omega naught plus pi delta omega plus omega naught. So this is the way we can write. Okay. If I take pi by 2 common out in this one, then this is going to be delta omega minus omega naught plus delta omega plus omega naught. Omega plus omega naught. Next, plus 1 by 2j common out. Then it is going to be 1 by omega minus omega naught plus 1 by omega plus omega naught. Then finally, if I take omega square minus omega naught square as LCM, then for what we are left with pi by 2 delta omega minus omega naught plus delta omega plus omega naught plus 1 by 2j. This is going to be 2 omega plus omega naught, omega minus omega naught get cancelled, 2 omega by omega square minus omega naught square, 2 get cancelled. So finally this is what the Fourier transform we are going to get. Pi by 2 delta omega minus omega naught plus delta omega plus omega naught plus, or if you take minus j, because j goes to numerator, minus j omega by omega square minus omega naught square. So this is what the Fourier transform for cos omega naught t u of t. Clear? Take it. Okay. Let's take an example. Let's call it is x of t. So this is nothing but cosine pulse. It is not a cosine wave. It is a cosine pulse which is existing only between minus pi by 2 and plus pi by 2. It is cosine pulse. For this cosine pulse, I have to calculate x of omega Fourier transform. How we can do this? Let's try. So if it is a cos function, we know how to write it. But it is not a cos function. It is a cosine pulse which is existing only between minus pi by 2 and plus pi by 2. So here we have to understand certain things. So let's say, if a signal is existing only for positive values of time, then we can multiply the original signal with u of t. Clear? In the same manner, suppose if a signal is existing only for negative values of time, that means we can multiply the original signal with u of minus t. What if a signal is existing for a duration? Then we have to multiply with a rectangular pulse. What do you mean by this, sir? See, suppose if I take cos t function, cos t, how it look like with respect to t? So this is the cos t function, 1 minus 1. If it is multiplied with, let's say, a gate pulse, that means rectangular pulse, which is existing only between minus pi by 2 and plus pi by 2, minus pi by 2 and plus pi by 2. Let's call it as a g of t, whose amplitude is equal to 1, So if any signal is multiplied with a rectangular pulse which is existing between minus pi by 2 and plus pi by 2, 1, then we are going to get original signal only between minus pi by 2 and pi by 2. Because it is a 1, we don't have to worry about any amplitude factor. So I am going to get the same function between minus pi by 2 and plus pi by 2. So here it is simply nothing but g of t multiplied with cos t is nothing but x of t. If I multiply these two signals, I am going to get x of t or not? Yes, definitely I am going to get x of t. So first let's say, for g of t, can you tell me what is g of omega for a rectangular pulse, symmetrically located rectangular pulse? We know what is that? Area sampling width by 2 omega. What is the area? Pi is the width, height is 1, so pi is the area. Sampling width by 2, that is nothing but pi by 2 omega, pi by 2 omega. So this is what g of omega. Now I got for g of t, what is g of omega, which is pi sampling pi by 2 omega. This is what the g of omega we got. Now if I multiply g of t with cos t, I am going to get x of t. So x of t is nothing but g of t multiplied with cos t. So it is nothing but a modulation property. If any signal is multiplied with cos omega naught t, here the omega naught value is equal to 1, then we know how to apply the modulation property. So that is going to give you 1 by 2 g of omega minus omega naught plus g of omega plus omega naught. But here omega naught value is equal to 1, so we are going to get g of omega minus 1 plus g of omega plus 1. So this is what we are going to get. So is equal to pi, if I take common, pi by 2 sampling pi by 2 into omega minus 1 plus sampling pi by 2 omega plus 1. So this is what the Fourier transform x of omega, x of omega. Take it. Suppose if I take a signal x of t having Fourier transform x of omega, What if I take a signal x of at, time scaling? Then the Fourier transform I am directly giving you 1 by mod a x of omega by a, This is very important. Suppose if I take x of t by a, so similar to this one, we have to multiply with mod a x of a omega. Or if I bring it here, 1 by mod a x of t by a, small x of t by a, x of a omega. So if you observe carefully these two formulas, what I am going to enclose, they look exactly same. How, sir? If I take x of at, this is nothing but 1 by mod a x of omega by a. If I take in the frequency domain x of a omega, then this is nothing but 1 by mod a x of t by a. So this is what the similarity what we have to observe. So for that case, I am not saying which one is the scaling here, whether it is time scaling or frequency scaling. It is both are okay. So here, if you observe carefully, x of at, that means time scaling, x of omega by, that is nothing but frequency scaling. What kind of scaling it is? Let's say depending on, if I take x of t, let's say having Fourier transform x of omega. What if I take x of 2t, x of 2t? Then we are going to get 1 by 2 x of omega by 2. So if you observe carefully here, this is nothing but time compression. Time compression. If you observe here x of omega by 2, this is nothing but frequency expansion. Frequency expansion. Frequency expansion. Suppose if I take x of t by 2, then we are going to get 2x of 2 omega. X of 2 omega. So if you observe here, this is nothing but time expansion. And here x of 2 omega indicates frequency compression. Frequency compression. So from this I can conclude, in one domain if it is expansion, in another domain it has to be compression. That's what the meaning of it. So here if it is expanded in the frequency domain, in time domain it is compression. In time domain if it is expansion, in the frequency domain it is going to be compression. Opposite. So compression leads to expansion, expansion leads to compression. This was one of the previous PSU question, IES question. They asked, so which property is going to indicate compression in one domain leads to expansion in other domain? That is nothing but scaling property. Clear? Take it. If a signal x of t, if x of omega is Fourier transform of x of t, then find Fourier transform of x of minus 2t plus 3. For this function, I have to calculate Fourier transform in terms of x of omega. That's the question. How? Let's say I told you, whenever there are multiple operations applied on a signal, then go one by one. That means first we have to start from what we know. What we know, actually they have given for x of t, x of omega. This is what they have given. So let's see one by one property I am applying. So first I will go for shifting, scaling, reversal. So let's say one by one. X of t plus 3. So from the time shifting property, it is going to be x of omega e power j 3 omega. E power j 3 omega. Shifting in one domain leads to exponential multiplication. Next, x of 2t plus 3. X of 2t plus 3. Time scaling. Then we have to say 1 by 2. Wherever omega is there, replace it with omega by 2. E power j 3 by 2 omega. Next, x of minus 2t plus 3. That means time reversal. So in the time reversal, wherever omega is there, that has to be replaced with minus omega. Then this is going to be 1 by 2 x of minus omega by 2 e power minus j 3 by 2 omega. So this is what the Fourier transform is. Okay, take it. For the similar case, find inverse Fourier transform of, let's say, x of 3 omega plus 2. X of 3 omega plus 2. So it is just given. So it is similar to this one only. That's why I have taken here. So again, we have to start what we know. For x of omega, what is the inverse Fourier transform? Which is nothing but x of t. So I will always take time domain in the left side and frequency domain in the right side. One by one again. X of omega plus 2. What is the inverse Fourier transform? So shifting in frequency domain means exponential multiplication in the time domain. So it is going to be x of t e power minus j 2t. So this is what it is. Next, x of 3 omega plus 2. So we have to divide with 1 by 3. X of, wherever t is there, replace with t by 3 e power minus j 2 by 3 t. So this is what the inverse Fourier transform for x of 3 omega plus 2. Take it. Let's take an example. Two signals which are given like this. Which is x of t with respect to t. Y of t with respect to t. Minus. So they want to calculate what is y of omega in terms of x of omega. So find y of omega in terms of x of omega. So first we have to know what is the relation between y of t and x of t. That is the first thing we have to know. Okay. Let's see. First of all, we have to see what is the width of the two signals. So here width is 4, here width is 2. So definitely we are having a scaling factor. Let's say A is equal to how much? So it is got compressed. It got compressed. So it is nothing but required width. Sorry, available width by required width. So that is nothing but 4 by 2. That is nothing but 2. So let's say if I calculate x of 2t, how it look like? This is going to be minus 1, 1. So this is what x of 2t. What I have to do with x of 2t so that I can get y of t? So we have to shift this signal in the left side direction by 1 unit. So left side direction by 1 unit means I have to advance. That means I have to replace t with t plus 1. Then we have to multiply with minus 1. So simply I can write from this y of t is equal to minus x of 2 into t plus 1. T plus 1. So this is nothing but minus x of 2t plus 2. So this is what the relation between y of t and x of t. So this is what we got. Now let's see one by one what we can say. For x of t, let's call Fourier transform is x of omega. For x of 2t, Fourier transform is, x of t plus 2, better, t plus 2. Time shifting, so we have to multiply with exponential in the frequency domain. X of omega e power j 2 omega, Next, x of 2t plus 2. Then this is 1 by 2 x of omega by 2 e power j omega. Next, minus x of 2t plus 2. Then simply here also we have to multiply with minus 1 by 2 x of omega by 2 e power j omega. So this is what the y of omega. So this is what y of omega in terms of x of omega. I hope you understood. So take it. So just we have to see what is the relation between y of t and x of t. So from that we can calculate what is y of omega in terms of x of omega. Question. Question number 8. Let's say here x of omega is given and y of omega is given. Y of omega. Then they have given what is the relation between y of t and x of t. So we have to choose one of the option. Option A, y of t is equal to 2 by 3 x of t by 2. Option B, y of t is equal to 3 by 2 x of 2t. Option C, y of t is equal to 2 by 3 x of 2t. Option D, y of t is equal to 3 by 2 x of t by 2. X of t by 2. So which option is going to be correct? Again we have to see what is the relation between y of omega and x of omega. What I can do so that I can get y of omega. So definitely in the frequency domain it got compressed. So and it is got compressed and scaled, amplitude scaled by 3. So I can say y of omega, simply we can write y of omega is equal to 3 times x of 2 omega. X of 2 omega. So if it is compressed by 2, so it is nothing but x of 2. So for this we have to calculate. So let's see. First, x of omega, we are having inverse Fourier transform x of t. Then x of 2 omega, what is the inverse Fourier transform for this? 1 by 2 x of t by 2. Then if it is multiplied with 3 x of 2 omega, then here also we have to multiply with 3. This is 3 by 2 x of t by 2. So this is nothing but y of t, because it is nothing but y of omega. So for this it is nothing but y of t. So this is y of t and x of t having relation. So which is nothing but x of t by 2, we are having 2. So it is 3 by 2. So option D is correct. So this is the relation. I hope you understood what is the scaling property here. Check it and then we will see in the next session.